How do you know this is a linear sequence? Yeah, when you look at it, what do you observe? It's always plus something or minus something. That's the rule. Either you had something to get the next one, had the same thing, which is this difference you guys are talking about. Do you get my point?
Yeah.
So, for example, I think we've said this before. Please, I need everyone's attention. Some people are doing a lot of side talks, and it's getting to the point where I can't take it anymore. If you have 15, 12, 9, 6, without doing anything, you could see that this is determined by what? The rule. Minus 3. So you don't have to do the difference pattern, but we could see clearly from here. That's how you know this is a linear sequence. For quadratic, you have to find the second difference to conclude it's quadratic, right? For cubic, you have to find the third difference. For exponential sequence, look at that paper. How do you know it is exponential sequence?
Multiple dividing.
It's always multiplying or dividing. Can somebody give me an example of an exponential sequence starting with 2?
2, 4, 6,
4,
8,
8,
16,
16,
20,
32, 64, like that. So this is an exponential sequence because you multiply something. Another one is 81, 27. What's the next?
9,
9,
3,
3,
1,
1,
1 over 3,
1 over 3,
1 over 6.
like that.
No.
Because this is divided by 3. So here you do times 2. Okay? In this case, are you listening? In this case, we say the common ratio is 2. Here you do divided by 3, right? Right?
Yeah.
Divided by 3 is the same as times what?
1 over 3.
So here we say the common ratio is 1 over 3. Does it make sense?
Yes.
Common ratio is the term before divided by the term, like the term in the front divided by the term at the back. So common ratio is like the second term divided by first term. Does it make sense? Look at it now. 27 divided by 81 gives you that 1 over 3. Not the other way around. You have to be careful. Okay? It should be the term, a step ahead, divided by the current term. That's how you get your common ratio. And it works for this too. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. That's how you find your common ratio. Does it make sense? Does it make sense, please?
Yes.
So in this case, we do not use this approach. Okay? The approach we use is the n-term formula. The n-term of an exponential sequence, I've written it in that paper. I just call it UN. It doesn't matter. Or you can just say n-term. So maybe we follow what we are used to. N-term is simply a times r to power n minus 1. Do you want to know why we have that?
Yeah.
Okay, let's see. Let's play around with some random sequence here. The first term is always denoted with A. What is it? Yeah. The first term, Elsin, the first term is always denoted with A. It's a general symbol for first term. Okay? A. If I want to get my second term, from these two, what do you do to get 4?
Times 2.
Can I have absolute silence? I don't know who is that baby playing with pencil or pen or whatever. What do we do to the first term to get the second term? Times 2. What do you do to this to get this? What is that 2 you are multiplying? What is that 2 called? Common ratio. Does it make sense? So you multiply by common ratio to get this. Multiply by common ratio to get that. Do you agree now? So, my first term, my second term, my third term, my fourth term, my fifth term. Can you see? My first term is A. I multiply by R to get my second term. So what is my second term? No. Come on. Again, my first term is A, my common ratio is R. I multiply to get the second term. So what is my second term? This is simply algebra. I don't expect everybody to be quiet at this point. Okay? I multiply by ratio again to get the third term. What is that? I multiply by ratio to get the next term. What is that? This will be. So look at this. If I continue, I want to get the nth term. What would that be?
ARN.
ARN.
ARN minus 1.
ARN minus 1. I have two options now. Look at it clearly and tell me which one is right.
ARN minus 1.
Because the first time is at R.
Can you see? So it should be, this has something like AR to power 0. Do you agree?
Yeah.
So for term 1, with position 1, I have 0. Position 2, I have 1. Can you see that? Position 3, I have 2. Position 4, I have 3. What did you notice about the position and the power?
So it's 1 less.
1 less. So position n, I have n minus 1. That's how I got the formula I wrote in the paper for you. Does it make sense? So the nth term of an exponential sequence is ARN minus 1. So now, if this is the nth term, what would you try to figure out to get the nth term if I give you a sequence? Two things you need to figure out to be able to get your nth term.
The common ratio.
What?
The common ratio. A and R.
A and R, not just the common ratio. Can we please speak with confidence? What are the two things you need to figure out to find your nth term? A and R. That's it. Not common ratio. In fact, A is the easiest one. Right? Why did I say A is the easiest one? It's the first term. You can, if you look at the sequence, there's always a first number, right? That's even the easiest one. Okay? So let's try to get the nth term of this. Everybody, please pay attention. I have 2, 4, 8, 16, 32. So again, you say A is equal to 2. That's easy, right? And the next thing, R is 4 divided by 2. Can you see that? Which is what? 2 as well. So your nth term, ARN minus 1, will be 2 times 2n minus 1. Is that right? Is this the simplest form?
No.
Why?
Because 2 times 2 is 4.
So I get 4
N minus 1.
n minus 1. Do you agree with her?
No.
Uh-oh. You don't have any friend here except me. What? What do you think?
2 to the power of 1.
2 to the power of 1
And then times 2.
times, wait, times 2 like this?
Yeah.
Okay.
To the power of n minus 1. So it's 2 to the power of 1 plus n minus 1.
Does this look familiar to anyone?
No.
Indices, addition of powers.
Oh, yes.
Yes.
What is a to power 3 times a to power 5?
8 to the power 8.
How did you get the a? Isn't it?
5 plus 8. 5 plus 6.
That's what she's talking about.
Oh.
Alright? So this will be 2 to power what now? N. Now let's see if this works.
I don't understand. Oh my God.
Let's see if this works. 2 to power 1 is what?
2.
2 to power 2?
2. 4, sorry.
2 to power 3?
8.
Can you see?
Yeah.
2 to power 4? 16. So this is indeed the nth term. So what part don't you understand? Do you understand this part? Do you understand this? A is 2, Alex. R is 2. It's just substitution. This is A. This is R. Okay, let's take the second one. 81, 27, 3, 1, like that. Can I ask you to try this, please? And try to put it in the simplest form. Try to put this in the simplest form. Please get this done, please.
Is that 81? It's clearly written. I don't how to get R. It's clearly written. Oh.
R is second term divided by first term.
Okay. Yeah.
Done?
Oh,
Wait, but why is it you make 2 times 2 4? Why do you make 2 times 2 4?
What did I make?
Why don't you make 2 times 2 4?
Okay, can you tell me why not make a times a squared here? Because I asked this and you said a to power 8 the other time.
So what happens if you have a times b? You keep it ab?
Yeah, that's a times b. It means a and b are not the same.
So you do, if you do a times b.
Even a times b has to be just a times b, not a to power something, b to power something else.
No, I'm saying if it's like a to the power 3 times b to the power 5, would you make it a b to the power 8?
No.
It would be H.
Just a cubed b to power 5, that's it.
Oh.
When they have the same base, you have the powers. Alright, quickly.
So it's
Is that the simplest form? Who has gotten 2? Up to the simplest form? You think. Can I see? Are you still thinking? May think. That's not the simplest form. Think further. Yes. Where does this come? Oh, wait. Oh, okay. But this is minus 1. So 1 and minus 1 gives you nothing. You're supposed to break this to give you this 2, not to produce something strange. Try the next one. If you don't know the simplest form of this, I will explain when I get to that point. Try the next one.
What? What did I do?
Raise your hand if you have attempted this. You don't have to get the last answer. Raise your hand if you have attempted it. Alright? So did you get 81? 1 over 3 n minus 1?
yes.
Alright, Joey, can you? Now, did you get this? Can somebody tell me what is wrong with this?
81 needs to be power.
No, the way I've written this, something is wrong.
You only do n minus 1 to 1?
Continue do it.
Yes. So what should I have done? There's need for a bracket. That's the first mistake some of you made. Alright? Because that power belongs to R. Is R just the numerator?
No.
No. So you have to put a bracket. That's number 1. Number 2 is this. Can I write this as a power of 3?
No.
Can I write 1 over 3 as a power of 3?
Oh, 3 to the power of 9.
That's it. What about this one? Can I write to the power of 3?
Yes.
Yes. So what is this as power of 3?
3 to the power of 4.
3 to power of 4. And
3 to power negative 4.
this is 3 to power of what? Negative 1. using your indices is part of the topics I'm going to revise. When you turn a number, when you flip a number, you negate the power. Do you remember that? That's what we are using. So this is 3, 4. Open this bracket now. What do I have? Joey, they can't see the board. Once you set it, please see it. They can't see from the back.
Minus n plus
So open the bracket. What do you have?
negative n
Negative n
plus 1.
plus 1. Now you can merge it with the addition law again.
Oh, there's more?
So tell me what to write. 3 to power.
5 minus n.
This is what I do not like. You're skipping how you did it. Yes? Because by the time you say 5, some people don't understand how it is. 4 minus n plus 1, right? Because when you add these two, that's what you get. And that's 3 to power what? 5 minus n. So this is the nth term in the simplest form.
Wow.
Okay? I can assure you, if you stop here, IGCSE will be merciful on you, but it's not so cool. Really.
So do I still get full marks out there?
Well, in some questions. But what if the question says, show that n term is this? It means you have to get to that point.
Okay.
For example, we are trying to test your skills of indices, which is what you apply here. So it means I will just give you a question, show that the n term is this, meaning I need you to simplify to this point. So don't try to stop here because, oh, they're going to give me my mark anyway. What if the question says stop here? Do you get my point now? So again, 1/3 is 3 to power 1. Do you agree with that?
Yeah.
Then I just repeated this. My times is repeated. This is this. Okay? Open the bracket. So when you open a bracket with power, you multiply the internal one by the one outside, right? So minus 1 times n is minus n. Minus 1 times this is plus 1. And I did the same thing I did in number 1. They have the same base. All I have to do is add the powers. That's what I did. And when you have this and this is what you get. Do you agree with that? And this is just to simplify it. That's all. What do you get for number 3? 5 times 2 to power n minus 1. That's right. That's the easiest one.
Oh.
This is what happens here. Do you agree with that? Isaac?
Yeah.
Do you agree with that step?
Yeah. Do you have a staple?
So open the bracket with the plus. Agree?
Yeah.
Then collect the like terms. 4 and 1 are like terms, right? So that's how I got 5 minus n. N is alone. There's no n term. Joey? No, I need you to because he's trying to see the board. While you're with Kelly, can you both go down a little bit? Yes. Do you understand this step?
I don't understand.
This one.
How did you
Okay. In indices, a to power m to power n, like that, is to power n minus times m. You multiply the one inside by the one outside. It's the rule of indices. It's nn, yes. So that's what we did here. So minus 1 times this. So that's like opening the bracket.
And minus 1.
No, minus 1 times minus 1 plus 1.
Yeah.
Has anyone, Anika, did you do this? What do you get? That's wrong. Why did you combine to get 10? Hold on, please. 5 times 2 to power n minus 1, 10 to power n minus 1. Can somebody tell me why this is wrong?
Because you can times 10 to the zero.
Why can't we do that?
Because
It doesn't make sense.
the infinite belongs.
It's not the same base, Anika. Can't. So this is where you stop.
Oh, that's where you stop. Okay.
We only proceed in this, we proceeded in this one, because you can have them in the same base. If you can't have them in the same base, you leave them alone. You don't look for trouble. Yes? We can, but this is okay. We can, but this is okay. Because you can split it into two. Kelly, can split it into two. 3 takes the power, 2 takes the power, 32 and 2 can match. Why 3 stands alone? But you don't need to do that. Do you understand? You get what I mean? Okay. You have? Is this what you have?
So when do you use AR and
Correct? So find a way to match this with this. But if you stop here, it's okay.
This is a different type of sequence.
This is called exponential sequence or geometric sequence. It has nothing to do with all this. Come. Whose calculator is that? Come here. Tell me what is confusing.
see how
Okay, so notice the number here. Try to look at the powers of that number. My common ratio is 2, right? Is this one a power of 2? So your calculator, you check it. If this number is 24, there's no way you can write it. For example, here my common ratio is 2. There's no way I can write 5 as power of 2. So it means I can't do in this case, I can write this as power of 2. Class, come on! But in this, I can write it like this. So that tells me something. Can I also write this as power of 2? This. Squared. So it means I can achieve 3 on this one and 3 on that one. Okay. Just try and error to check. Okay. If you cannot, you stop there. Okay. Any problem with this exponential sequence? No problem? It's okay? What if I give you this problem? What is, oh no, like, oh no, we're gonna die. No, you won't die. Are you ready? Can I? Try this. Try it out. sounding like I'm killing you with questions. These are simple problems, guys.
Kill me.
It's like, oh my God, I'm not coming to school tomorrow. Mr. Daniel is killing me already. These are simple problems, you lazy bones. It's almost time, guys, quickly. We have 5 minutes only. Can I ask you to please be quiet and get it done? Yeah, that's right. So go to the next one. Stop looking around and try to fix this problem. Come on. When I write a GP, what does it mean? Now I need to sue Mr. Hewitt on this one. This is not
Growing population.
Oh my God, that makes sense actually.
Yeah.
June.
Oh. Geometric poverty. Oh. Poverty.
Yes, geometric poverty.
You know what that means? It's the same as exponential sequence.
No.
Okay, we call it GP, geometric progression, or geometric sequence. All right, quickly. Quiet, please. Quiet, please. Quiet, please. Get the work done. Thank you.
Mamma mia.